The derivative of the inverse function is the reciprocal of the derivative of the function with the other variable plugged in. Let me explain. I want to take a look at derivatives of inverse functions, and in relation to the derivative of the function that they're the inverse of. So if you know the derivative of a function, can you use that information to find the derivative of the inverse function? So here's, I'm going to draw a graph of an invertible function. I'm going to make it look like an exponential. It doesn't have to be an exponential, but something that's invertible. This just keeps it out of the way by putting it over there. So the inverse graph would look just like it, only flipped over the line y equals x here, right? So if you think of that as a mirror and reflect everything down here, let's see if I can do this reasonably well. Something like that. Then what I want to do is I want to look at how slopes of this curve, this was y equals f of x, will tell me about slopes of this curve, y equals f inverse of x. Okay, so let's pick a point here on the graph of the function. So this is a and this is b. If the point AB is on the graph of y equals f of x, then there's a corresponding point, reflect that down here. This is b and a, so the x coordinate a turned into the y coordinate a there, and the y coordinate here b turned into the x coordinate over there b. Okay. X's and y's get reversed. So now what I want to do is I want to take a look at slopes of tangent lines. So for instance, if I know the slope at this point here, in fact I can calculate the slope using the derivative, that the slope equals f prime evaluated at the point A, right? What does that tell me about slopes on this graph? Well, it doesn't tell me anything about x equals a, but it does tell me something about the reflected point over here, that this tangent line there is somehow related to the tangent line up here. Well, I can, and the slope of this line, let's take a look at the slope of this line. Well, the slope is going to be the derivative of this function evaluated at that x value. So it's going to be, take the inverse function, right, that's the function I'm on, take its derivative and evaluate that at the point B. Okay, so the slope equals that. Now, I want to see how it's related to the slope up here. How are these two slopes related? Well, the key comes in to realizing that the slope is rise over run. And then when you reflect that down here, what was the rise is now a run. What was the run is now a rise, that the roles of x and y swap. So actually the roles of rise and run swap. And that the slope of this line down here is the reciprocal of the slope up there. That is, this is 1 over f prime of a. This slope is the reciprocal of that slope. So there you go. What I said to start with was that the derivative of the inverse function is the reciprocal of the derivative of the function with the other variable plugged in. This is an a, that's a b. We'll take a look at many examples of how this works.